Okay, so today we're talking about mineral identification, and Chloe suggested that I make a video with the webcam to give you some hand motions. So hopefully you like that. If not, let me know and I'll take the webcam off for next time. But if you direct your attention to the presentation, if I could just make it a little bigger, I'm going to move myself just for a second, and I'll move myself back. All right. So we're going to talk about how to properly identify minerals using their chemical properties. After this video, there will be another video with the gentleman that goes through a bunch of different mineral samples and classifies them. So, mineral identification map. We can go through this based on their physical and chemical properties. So, one way you can identify a mineral is by its color. The color of a mineral is a result of their light absorption and reflection ability. Color you see is usually what's being reflected, and based on what colors of the spectrum are being absorbed. So we'll learn about that when we look at the electromagnetic spectrum. But color is a big indicator, but it's not always the best way, and we'll talk about what might be the best way to identify a mineral. So minerals can have different color variation. Some differentiation is due to impurities that are trapped in the mineral during the formation process. So that's why sometimes it can be difficult to classify a mineral based on its color. So I got ahead of myself. Due to the variations of color that can arise throughout the formation of the different minerals, it's not always a reliable indicator of the mineral's identity. So we kind of can start with color because it's the most obvious of the properties, but we definitely want to move down the list of different ways to identify. So the next, before we do that, these are different colors of quartz, and they're caused by impurities within the formation. And then I froze for a second there. That's nice. So streak. This is another way to identify a mineral, and streak is the color that's produced when a mineral is rubbed on a streak plate, and you'll actually get to do this in a lab this week. So I have a few streak plates and a few mineral samples, and the way you test for streak is using sort of like a looks like a piece of tile, and what happens is the mineral, as you scratch it along the surface of the streak plate, will produce a color, and that color is the powder version of that mineral. So it's more reliable because it's not based on the physical appearance of a mineral, it's based on a chemical property that is the same no matter what mineral sample it is. So the color of the streak produced when a mineral is rubbed is consistent for all minerals. So I have another example before I move ahead of myself. So all the different colors of quartz that I showed you in this picture, if you rub them on a streak plate, they will produce the same color. So it's a better way to say this is a sample of quartz. So streak is more reliable than color. But let's look at some other properties. Another property is luster. And so luster depends on how the mineral reflects light. There are many different words and I spelled describing wrong. Wow. When describing a mineral's luster, but the best way for us to do this is to relate it to something we can visualize. So when we're talking about the luster of a mineral, we're going to say it's shiny, it looks like glitter, it's dull, or it's metallic. So there's different ways to explain this characteristic of a mineral. Another property that we can use to identify minerals is transparency. So this is the clarity in which we can view another object through the mineral. So whether or not that mineral is transparent or not. So there are more specific terms that describe different types of transparency because not all minerals are completely transparent, but some do have visibility when looking through them. So for example, this sample of, looks like halite. You can see the color, if you look beyond the halite, you can kind of see the reddish color shining through, so it's considered to be transparent. So you would write down that this mineral sample is transparent, since you can see that little red or shade of burgundy shining through. I guess that was a good word. So if an object can be seen through the mineral, but does not have a distinct outline, it's considered semi-transparent. So you can have an in-between. You can kind of see that there's something shining through, but it's not really clear as to what it is. So this mineral sample is considered to be semi-transparent. When a mineral cannot be seen, or when you cannot see through a mineral, I don't know what I was thinking with this fuzzy, but when you cannot see completely through a mineral, but it's transmitting light, it's called translucent. So you can't see through this mineral, but it is transmitting light. And when a mineral does not transmit light and does not show any sort of image, you would say it's opaque. So this sample, there's nothing showing through it. It's completely opaque. So the other way we can classify a mineral is the formation of the crystals. And so sometimes this can be a little hard to see, because mineral samples, especially the ones that I have, they're usually taken from a source. So you can see the formation of crystals very clearly in places like caves where there's large samples and you can see how the crystals line up. So there are different categories of crystal formations. Crystals can make up the mineral, have completely and perfectly to form a solid structure. The crystalline crystals that make up minerals of this type are imperfect and were disruptive to each other during formation. You have microcrystalline, you really can't see the crystals, but they're visible on a microscopic level. And then there's glass, where that during the formation of this type of mineral, it cooled so quickly that there really is no just orderly structure that contains crystals. Another way we can classify a mineral is how it breaks. So cleavage is a mineral that splits in a certain way, and it's sort of like a clean cut. So this is better when I compare it to the next property, which is fracture, but a mineral that splits in specific directions when under pressure or struck by another object and it's a clean cut is said to have cleavage. Skip over that for now. Fracture is how a mineral breaks aside from the cleavage plane. So if you can see here, this is kind of jagged. So when we strike this mineral sample, you'll see jagged edges and it won't have a clean split. Also, we can look at the hardness of a mineral. Woo! I don't know why I didn't kind of like that. Anyway, so the hardness of a mineral, this is, we use Mohs hardness scale to determine a mineral's scratch resistance. Sometimes you can test minerals on each other to see which one is harder, and we'll do that in our lab and it'll make more sense. But the hardness of mineral is determined to the resistance of being scratched by the minerals used as reference points on the Mohs scale. So you have a reference point of talc, which is very soft. Talc really can't scratch anything, so it's got a very low level of hardness on the Mohs scale, and then whereas diamond is considered to be very hard, and so that diamond will scratch other surfaces, but it won't typically be scratched unless it's with another diamond. So this is the scale right here. You can't see the diamond at the bottom, but see, talc has a scale of 1 where diamond is 10. So diamond is considered much harder than talc. Talc is a very soft mineral, and so if we were to scratch calcite or rub calcite and talc together, we would see that the talc powder would be left over on the calcite because the calcite is scratching the talc. Therefore, calcite is harder. Also, you can look at their special properties. Sometimes some minerals can have magnetism. So they can have polar, they can have magnetic fields, and we can test these using things that would stick to the mineral based on its magnetism. So we can test for that as well. Effervescence is the fizzing, it's something that you can observe if you were to add an acid. So we'll have very diluted hydrochloric acid to test on different minerals. If you observe a fizzing reaction, then it's said to have effervescence. We don't want to taste our minerals, but sometimes minerals will have distinct taste, like halite. Halite is salt, so it will be salty. Odor, some minerals are smelly. Sulfur smells pretty bad, and it does give off a smell when you scratch it on a street plate. So we do have some sulfur, and it tends to smell like rotten eggs. And that's our lesson, or this portion of the lesson. So I hope you enjoyed it, and feel free to watch it again. You have time to watch it again and to take notes. I know I tend to speak pretty fast. Hopefully I made some sense.